All right, so we are looking at how to solve some pretty simple equations using powers and roots. So to solve equations using powers and roots, we're going to use the opposite operation. So in terms of powers and roots, you should be writing opposite in the blank. So in terms of what we know so far, a square root and a square are opposites. So I just kind of made a little superscript 2 there that's sort of little and above. A cubed root and a cube are opposites. So just like when we solved equations with adding and subtracting, this is just with these. The symbol plus or minus means positive or negative. We're going to use that symbol some today. So plus or minus 3 means positive 3 or negative 3. So take a moment, if you haven't filled in all those blanks, get all of those done. And then we're going to solve these. Actually, we might not need our calculators for this first part. That's okay. We can talk about it. All right, so if I have x squared equals 25, what we do to both sides of the equation is we want to get x by itself, so we want to get rid of the squared. The opposite of squared is a square root. So I have to know what the square root of 25 is. What is it? It's 5. Now, I'm going to add a little thing to this. If I take 5 times 5, I get 25, but I can also get 25 if I take negative 5 times negative 5. So there's technically 2 answers. And somebody got really tired of writing 5 or negative 5, so they invented this symbol, plus or minus 5. So basically this includes both answers, and it doesn't take very long to write. So if you are taking a square root, you should always have a plus or minus in front of the answer, unless they're telling you that they just want the positive one. For a lot of story problems that we're going to look at, the Pythagorean theorem we'll look at, we'll only want the positive one because the negative won't make sense. But we'll have to just look at that in context of the problem. So for number 2, to get rid of the squared, and you could write this on the first line. I'm just doing this on the next line so my notes are super clear. To get rid of x squared, I do a square root. I'm going to put my plus or minus sign, and then I have to know the square root of 49, which is 7. So you could check this. If I put 7 in, 7 squared is 49, and also negative 7 squared is 49, because a negative times a negative also makes a positive. So that's why both of them work. Okay, so let's look at what happens if we change it to a cube. So essentially we're going to do the same type of thing, except that this is a third power, which means I need to take a cubed root. Let me rewrite this so it's neat. So we're going to cube root both sides of the equation. That gets rid of this power. This and this cancel and leave x on this side. And then I need to know the cubed root of 8, which is 2. Now, let's think about this. Do I need plus or minus on this?
No.
Okay, so let's think if I have 2 cubed, that's 2 times 2 times 2, that's 8. What I'd have to ask myself is if I put negative 2 in, I'd have negative 2 times negative 2 times negative 2. That would give me negative 8. So technically, I forgot to put the cube on it. So technically, this is not an answer. So for the cubed root, the answer is just going to have the same sign as the problem. So on number 4, to get rid of x cubed, we take the cubed root, which is why I had you guys learn some of these. And what's the cubed root of 64?
4.
It is 4. And again, we would not have the negative on there. Now underneath this, there's just a tiny bit of space or above. Let me do one where it was negative. Let's say instead of 64, it was negative 64. You can do the cubed root of a negative, and what this would mean is that x is negative 4, because negative 4 times negative 4 times negative 4 would come out negative. So on cube roots, we can put a little note that the sign is the same as the original number. And then over here on the squared roots, you're going to need to do plus or minus. And that becomes a really big deal in high school over the next couple of years. Sophomore year especially, we start looking at quadratic formula and some of that stuff that we go into. This becomes a big deal. So it's important that we learn this little tidbit now so that it makes high school easier. 8th grade, sort of that year where we're transitioning you, getting you ready for bigger and better things. All right, so down here it says when you square root both sides of an equation, you will have two solutions. One is positive and the other is negative. So I just used a plus and minus sign there. You could write the words positive, negative. There should be room there if you want to write that all out. So now we're going to solve equations that have roots in them. So this is the opposite. So if x is trapped inside a square root symbol, we're going to do the opposite of square root, which means that I'm going to square both sides. If I square a square root, that just gets x by itself. But if I square the left side, I have to also square the right side. So that means that x is 3 squared, which is 3 times 3, which would be 9. You can also think of this as what would I take the square root of to get 3? So when you plug this in, you want to check, does the square root of 9 equal 3? Yes, yes it does. So on this one, the opposite of a square root is to square. So we square both sides of the equation. What is 5 squared? 25. And then you could check that and say, okay, does the square root of 25 make 5? Yes, it does. That's one of the solutions. All right. So then when you see a cubed root, we're going to do the same thing, except because this is a cubed root, we're going to use a cube, or a third power to both sides. So this and this just cancel, and that sort of gets x out of jail. That's how I always think of it. Like this is the key that unlocks the, I don't know why. I have a really complicated way of thinking about that. And then 2 cubed is just 2 times 2 times 2, which would be 8. And you can check, is the cubed root of 8 2? Why, yes it is. And then on the next one, we take what we have and we're going to take it to the third power. So we get x over here. What is 7 to the third power?
329.
So if we don't remember, you could take your calculator and do 7 times 7 times 7, or use the power key. It is 343. And then if we check, okay, cubed root of 343, you could check and use 7. And there is a way to check these on your scientific calculator, so I'm going to show you that really quickly. The square root button is right here above this. So if I wanted to do the square root of 25, I could do second and that button and put in 25. And that gives me 5. So that's the square root is above the x squared. And then there's one that just has an x. It's right here above your power key. And so what we do with that one is if I want to take the third root, I think we hit 3, then second and that button. And then let's say we're taking the cubed root of 8. It gives you 2. So you have to put a number right here. You can't see it really well. There you go. You have to put the number here that goes in there. So since we wanted a cubed root, you have to tell it that x is 3 and do that. But these scientific calculators are really cool. They have the ability to do these. Some of them actually have a cubed root button, but this one doesn't. Usually they just have that x root, and you have to tell it it's a cubed root. But you could do 4th roots, 5th roots, anything with that key. Okay, so let's go to the other page and just look really quickly at some applications. So the area of a square is 64 inches squared. What is the length of a side? So the thing we know about squares is that the sides are all the same. That means the length is x and the width is x. which means that the area, since we just do length times width, is x times x, which is x squared. And then we also know that that's 64. So we could think of it as 64 is x squared. So then what would be the length of the side? Yes? 8. And then if I wanted to show this, I could just square root both sides, and we get 8. Now, when we did these before, we did plus or minus 8. Tell me why negative isn't on this one.
Because it's not.
Okay, so would I ever have a square and go, okay, this is negative 8 and this is negative 8? Do we use negatives for length usually? No. We use it for direction, not so much for length. And so on this, we just need 8 inches. We don't usually have a negative inches or negative feet or anything like that. Just regular, normal numbers. Okay, so on number 2, the area of a square is 49 square centimeters. What is the length of a side? So you would have the same setup. Basically, 49 is x squared. And then you can square root both sides. And that gets rid of the squared. This is just sort of explaining how this is opposite. And then you know that 7 centimeters would be the length of the side. So that means on your square I have 7 centimeters times 7 centimeters. And when I take length times width, I get 49. So that all checks out and makes sense. So those are fairly simple because they're squares. They're also expecting us to use this with cubes. Remember when we did volume, that whole unit on volume? Well, this is just another little add-on that's going to go with it. The volume of a cube is 27 cubic feet. What's the length of an edge? So if we think about a cube, I'm just going to draw a quick one really quick. The length. So cube is a box that all of the edges are the same. Length, width, and height will all be the same.
But it's just like cubes for a reason that are a little bit.
Yeah, yes. Okay. So for the volume of this, length times width times height is just the same number times itself 3 times. So we could think of it as x cubed. And then we know that that's 27. So if 27 is x cubed, then I think if I'm understanding what he's saying, we're just going to cube root both sides.
Yeah.
And we end up with, what's the cube root of 27?
3.
3. And then I'm going to label this feet because it is sides on a cube. And then once you kind of have that down, for the volume of a cube is 1,000, I could just go ahead and go, okay, 1,000 is x cubed. And I just know to solve that, I have to do the opposite, which is a cubed root. And then what is the cubed root of 1,000? 10. And then this is centimeters, so I'm going to put centimeters on my answer. So the first one, I drew a picture just to reason it through. So squares and cubes are special because all of the lengths are the same. And this is a shortcut that can be used to find that missing information. All I have to have is that total volume or that total area to do the other. So we're going to do a quick practice on this, and I'm going to check, and then we're going to do another lesson. So